My name is Aether Knox, and this is an introduction to programming in Resonite. Data is what a programmer manipulates in order to create functional systems. You can think of it as a programmer's modeling clay. In programming, you will be working with two different types of data. You'll be working with numbers, and you'll be working with letters. As far as numbers go, there are a lot of different types. However, the two major types you'll be working with in Resonite are integers, whole numbers, and floats, which are fractional numbers. Integers include 1, 6, 172, etc., anything that doesn't have a decimal point. Floats are anything that does have a decimal point, 1.2, 0.01, etc. As far as letters go, there are only two major types. There's chars, or chars as I like to call them, because the type is short for character. R, T, S, literally any letter of the alphabet. And then you have strings, which are whole sentences. You can think of strings as a literal string of characters. It's important to keep in mind that you won't be dealing with chars very much in Resonite. However, knowing what they are can help you understand what strings do a little bit easier. If you've done any sort of research into programming in the past, you might have come across the term variables. Put very simply, a variable is a container for data. And although that term for it isn't used in Resonite a whole lot, the concept still exists. And it's important to learn this concept because then you can know exactly what to do with variables. Individual variables can only contain one type of data at a time. So if you have a variable, it can only store an integer, for example, or a float, or a character, or a string. However, a string variable cannot contain an integer or a float, and vice versa. Variables are also referenceable. However, exactly what that means we will get into at a later time. Functions are bits of code that manipulate data. They contain data themselves, and they are used to perform actions. Protoflux, or Flux for short, is Resonite's way of creating functions for you to perform actions. We will be taking a look at the anatomy of a Flux node in this video, but we will be programming in a later video. So it's important to get a keen grasp of what these things look like and how to decipher their language, so to speak. The anatomy of a Flux node is very simple. You have inputs on the left and outputs on the right. A Flux node has a different function or job to do, and you use them for different purposes. Unfortunately, there are too many to go over in any one video, so you should be able to learn them as you go. I will try to explain what each Flux node does as I go to program, but of course that is outside the scope of this video. Some Flux nodes have variables attached to them. This, however, is a bit different because this can either accept an existing variable from an inspector, or you can use this to create a new variable. We'll go more into that as we learn how to write functions in Flux. There are similar data types to variables known as constants. Where variables, you can change the value of them in runtime. With constants, you can't change the value of them at all. However, they are still containers for data. It's just a specific data that doesn't change. The lines between what a field is and what a reference is can get blurry pretty quickly, but I'll do my best to explain the difference. Earlier, we talked about variables and how they're containers for data. However, what we didn't mention is that variables cannot have any actions taken upon them, except for changing the value stored within them. Fields, on the other hand, are a little bit different. They are still containers for values. However, they can have actions taken directly onto the field instead of just on the value stored within. On the inspector panel to my left, you'll see a value field component. This is the name of a component, which we'll go into later when we go into inspectors. However, the fields are the words on the left. You can see it has 4 of them. It has a persistent field, a order offset, or an update order in this case, an enabled field, and a value field. All of these contain 4 different types of data. You have 2 booleans, which are true or false values, and then you have an integer, and then you have a float. A field, as I stated before, is a container for values similar to variables. Alternatively, references are simply fields meant to use objects instead of values. What is an object? In programming, an object is a complex data type meant to represent things that can't be represented with simple numbers or letters. You can think of an object as a physical object like you would find in real life, something that you can't describe with a single word or a number. Slots are the most basic and most common form of object in Resonite. They're the ones you'll be working with the most. By default, they come with a single component, which is a transform component. Basically, it just tells it where the slot is in the game world. Components are add-ons for slots, and they allow you to add features to the slot. For example, some components are variables, or they contain variables. Other components will allow you to perform an action. However, they all share the same type, which is type component, and they all will go under a slot in an inspector. Programming is a complex topic, and it's not for everybody, but if you're dedicated and willing to learn, you too can become a very good programmer. That pretty much concludes this video. I just wanted to go over some basic details and information on what you'll need before you get started on your programming journey at Resonite. In the next few videos, we'll get more hands-on, and we will start working directly with data and creating functions of our own. Any information that I've missed in this video will be explained later, so if you have questions, they might be answered in the next couple videos. Who knows? I think that's about it. Thank you all very much for watching, and I will see you all in the next few videos.